viewers. In the previous class, I was discussing about Lewis electronic theory and the limitations of Lewis electronic theory I was talking about. And in this lecture and in this video, I would like to discuss about the very important concept in the chemical bonding is about bond parameters. So I want to discuss. So bond parameters is the concept from chemical bond lesson. So what are the bond parameters, and so what the bond parameters will explain what we understand from this for the chemical bonding. So bond parameters are nothing but characteristics, properties of covalent bond especially. For understanding of the covalent bond, so these bond parameters are useful for us. So what are the characteristic properties of the covalent bond? How these characteristics can help us? The characteristic properties of covalent bond help us to know the structure of the molecule, and if you know the structure of the molecule, we'll understand the properties of the molecule. We'll understand properties of the molecule. We'll understand the if you understand about the properties of the molecule, we'll understand the stability of the molecule. So our ultimate aim is that to understand about the stability of the molecule. And if we want to know about the stability of the molecule, then we must know about energy state of the molecule. And this energy state, if you want to understand, then we must know about bond enthalpy, bond dissociation energy. We should know this is one of the parameter. And not only bond enthalpy, the bond enthalpy depends upon one more character is bond length between the atoms present in the molecule. The bond enthalpy depends upon the bond length. So we must know the bond length, the distance between the two atoms also we should know. And so bond length between the atoms, if you want to know, means then how many electron pairs are shared between the atoms also we must know. That means we must know the bond order between the atoms. Bond order means number of bonds between the atoms: single covalent bond, double covalent bond, triple covalent bond. So how many pairs of electrons shared by the two atoms we must know, that is about the bond order. And fourth one, if you want to know the shape of the molecule, then we must know bond angle. We must know. And so last one is, so if you want to know the stability of the molecule in detail, so we must study about resonance. Resonance is a phenomena we must study. So these are all the parameters bond length, bond enthalpy, bond order, bond angle, bond resonance. So all these properties, that means all the parameters, if you study, then you'll understand. So detail characteristics of, or we'll learn about the covalent bond. So let us start discussion of this bond parameter one by one. We'll discuss. So let us begin with very important bond parameter is about number one. The first one we'll start with so bond length. Bond length. So mostly this bond length and bond length, bond order can be measured by using X-ray diffraction technique. Number two, spectroscopic method. Spectroscopic, by using spectroscopic methods. So we'll measure, or we get the bond length. So let us start. Yeah. So now we discuss. First one is the bond length. What is meant by bond length? What is bond? What is a bond length? What is a bond length? We have to discuss. But the first one is, so the definition of this bond length. So bond length is nothing but simple form, simple definition I'm giving. The average bond, average distance between the centers of nuclei of atoms bonded, chemically bonded in molecule. This is one definition. The more comprehensive definition is the equilibrium distance between centers of nuclei of atoms bonded chemically in a molecule is called bond length we say. So bond length is nothing but the distance between, if you assume that atoms are spherical in shape, it has a center, and another atom also bonded to this, another atom has that spherical, it has also center. The distance between the average bond distance between the two centers of the nuclei bonded atoms, so is called bond length, which we measure in terms of picometers. 1 picometer equal to 10 to the power of minus 12 meters. Or if it is measured in terms of nanometers, 1 nanometer is equal to 10 to the power of minus 9 meters, we say. The distance between, since atoms are very microscopic, so if A and B atoms are bonded by covalent bond, so the distance between them, the distance we should consider from their respective centers. So that distance is AB distance is the bond length which we express in terms of picometers. If it is the chlorine molecule, A is the chlorine molecule, sorry, A and B atoms, so are chlorine and chlorine atoms. So approximately the bond length will be how much? 198 picometers. So how these are bonded means these are bonded by covalent. So bond we say covalent bond length we say this is covalent bond because so both atoms will share single electron pair then resulting single covalent bond. Between chlorine and chlorine the bond length is 198 picometers. And if you know the covalent bond length, then so half of this distance is said to be, so half of this distance, if you measure half of the distance, if you take this half of the distance is said to be what we call means covalent radius. We call this covalent radius. So if you take average bond distance, covalent bond distance, half of the covalent bond length, if you take 198 picometers upon average, if you do by 2, if you take, so how much it would be? 99 picometers. 99 picometers is the covalent 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 radius of chlorine atom. That means the chlorine atom is assumed to be sphere and the radius center of the nucleus to the outermost shell is said to be radius we call. So that means the covalent radius we get 99 picometers of the chlorine. That means if you know the radius, we get the bond length, covalent bond length. So if you want to get the radius of A atom and radius of B atom, though some of the radii of both atoms is said to be what we call means. So the bond length of AB atoms we say. Okay. Some of the radius of. So now let me take atom, the radius of A atom R plus the radius of B atom, sum of their radii is equal to bond length of AB atoms is the bond length. So the two atoms radius, if you sum up this, you will get the radius bond length in between the AB atoms we can get. Or so if you want to get a radius of A atom is equal to so bond length AB upon 2. If you do average of this bond length, then we can get so a radius of single atom if both atoms having identical properties. So whose electronegativity almost all electronegative values are same, then we must do the average. Then we can get the radius of the single atom. We can get the radius of the single atom. If A atom and B atom having the different electronegativity or electronegative values our electronegative difference is high. Electronegative difference is high between these two atoms. Electronegative, so difference is there. Then we have to use the formula DAB is equal to AR plus BR minus 0.09 AR minus BR. This is the formula. So we use to find out that bond length of AB atoms whose electronegative difference is high. So by using this formula, we can measure. Now, let us discuss how this bond length is affected by electronegativity, how this bond length is affected by the size of the atoms, how this bond length is affected by. So let us discuss factors that affect the bond length. Number one is size of the atoms, size of the atoms. Number two, electronegativity difference, electronegative difference. Number three, sharing of number of pairs of electrons, which is nothing but bond order. Bond order, we say. So size of the atoms, how the size of the atom, if the size of the atom is a bigger one, the size of the atom is a smaller one, always the small atoms will make bond length shorter. The bigger atoms will make bond length is a longer. Example, Hi bond length is longer, whereas HF the bond length is shorter. Here this is the shorter bond length because fluorine small size and pulling the electron pair towards itself, whereas iodine electronegativity is less, bond length will be longer. This is one example we can say. Electronegative difference. If the electronegative difference between atoms, so HF is there, the bond order will be very bond length is very shorter one because fluorine has high electronegativity. So bond length is affected by electronegativity. So tendency to pull the electron pair towards itself. And sharing of number of electron pair, single bond length is longer than double bond. Double bond is so means single bond length is longer than the double bond. Double bond is longer than what means triple bond, we say. Whereas between carbon, the bond length is around 154 picometers, which is high. So, and if you consider the triple bond CC, and it will be around, so double bond will be around C double bond is around 141 picometers, 42 picometers. So whereas a triple bond, so 120, so or 125 picometers around this is. So as the number of pairs of electrons between the atoms increases, as the number of shared pair of electrons between the atoms increases, the bond length decreases. Bond length decreases. The number of bonds increases. So let us between the nitrogen atom, if you consider triple bond, the bond length is around 109 picometers. And if you consider carbon and oxygen double bond, it is 122 picometers around double bond between carbon and oxygen, nitrogen and nitrogen 109 picometers. See, as a number of bonds, so between the bond multiplicity increases, bond length decreases. Bond length decreases. You must remember this. bond length decreases. And so how this bond length affect bond length affect bond length affect bond enthalpy also. Bond enthalpy. How this bond enthalpy? So what is a bond enthalpy? Bond enthalpy, minimum energy required, the amount of energy required to break 1 molar bonds between the atoms, the amount of energy required to make gaseous atoms is said to be bond enthalpy. The bond enthalpy depends upon the distance between the bonded atoms. More is the distance, bond length is longer, energy required is less. The bond length is shorter, energy required is more we say. So bond enthalpy depends upon distance between the two atoms, and the bond enthalpy also depends upon bond order also. So that means triple bond energy we want to break, energy required is more, and comparison with single bond hydrogen. So if you want to break, energy required 435 kilojoules per mole, whereas nitrogen, so bond breakdown 935 kilojoules per mole. So this depends upon the bond length, right? So if you want to see the bond length between hydrogen single bond pair, both hydrogen atom will share, the bond length will be how much? 74 picometers bond length. And if you want to see, so between hydrogen and oxygen, the bond length will be how much? 96 picometers we say. And if you want to see between carbon and hydrogen, the bond length is how much, so 107 picometers.